All right, so let's see some reminders. Your lab number 3 is due tomorrow by noon. Even if you haven't completed yet, submit your best attempt, and I'm going to release a solution for you to walk through so you can complete your learning without delay. And for your lab number 4, it's going to be a challenging lab, so I'm going to release that in time tomorrow. That one will have to be with the inheritance, but I don't think we will really start covering the substances of inheritance until Tuesday. But don't worry, lab 4, for a good part of it, you don't really need inheritance per se, so you can definitely get started. It doesn't hurt to get started earlier. And for your programming test number 2, I understand that your drop deadline is next Friday. I'm going to reach out to TA today, but depending on their availability, they may not be able to do kind of like a grading as a priority. I'll try to convince them to really do it. My really intention is to give you the result by your drop deadline, by next Friday. But if we really cannot, unfortunately, it may have to be Monday following. But I'll try my best. I'll keep you posted about the grading process. Okay? If I can release earlier, I'll definitely do that for your feedback. All right, any questions? Any question about the course in general? Any concern? All right, if everything's good, why don't we move on? And no inheritance just yet. We need to finish 2 more topics, but they are also fun topics as well. Let's now do a quick recap. So last time, we actually finished off the last example about equality. So that one there is really about how you can deal with a class like a person collector, where you got an array of objects. Of course, it doesn't need to be a single array. It can be multiple arrays as well. But that example should be sufficient for you to get started. And we talk about how to use the Boolean variable, like an equal over here, to control the entrance and exit for the loop. Because if you've got array attributes, unavoidably, you have to use a loop to really implement the equals. All right, so we talk about the detailed tracing of this method here in 1, 2, 3, 4 different scenarios, right? You want to dive into the details for each one of them. As I mentioned that the source code for the example here has been released on the lecture site since I started talking about this lecture. So I would highly recommend you try to dive into breakpoint and debugger and try to trace through this example one by one, line by line. Okay? That will be the best way for you to get prepared for not just written test number 2, but also for the exam. And we started the topic about call by value. It's not a difficult concept. I would say the only principle that's new is whenever you got a line of method call over here, you got a callee, and then you got a caller, the context over here. What you got to do is to make sure you connect. This is where the method is being called, and this is where the method is being defined. So these are the 2 different contexts. And there is some implicit variable assignments, namely paren. The parameter is assigned to the arg. This is the only thing you have to really remember that you got to do implicitly because, before you actually start tracing the code, whenever call by value is actually involved. And of course, in reality, you don't need to do this variable assignment yourself. It's done behind the scene for you. And we spoke about actually 1, 2, 3, 4, 5 different examples last time, right? You want to go over them one by one. Specifically, you really want to avoid doing something like this. If your parameter is a reference type, for example, point, you should never ever try to reassign the parameter into some other objects. Not only that, it's kind of logically wrong because that shows that you don't really understand what call by value really does for you. Because if you simply reassign the parameter used to point to the same objects as the arguments, if you assign that to something else, it has no impact on the original arguments. So doing that is useless, right? So you really want to make sure you avoid doing that. And of course, in the test or exam, if I give you a piece of code that tries to demonstrate this wrong usage, you should be able to identify it and explain to me why it is bad. Right? We talked about all these details last time. All right, so that's about call by value. And also we try to connect again, equals method call. It's just a method call. Of course, call by value apply. In that way, you can try to think about how the OBJ is actually a copy of the argument. For example, in this case, P3. Right? I made that last connection. before the end of the Tuesday's lecture. All right, any question? Equals method, call by value. These are all important topics. All right, and then I'll leave the review to your part. If you got any questions, concern, please reach out to me. We still have a few weeks, not a few, actually about 4 weeks left for the semester. We still got quite a bit, to learn. And then maybe after the last day of class, I think our exam is happening pretty soon. I think it will be the following Sunday, if you see the exam schedule. So what I will try to do, maybe not to disturb you in the study day, I'll try to schedule maybe 1 or 2 review sessions before the exam, so you guys can still ask me questions. All right, let's do that. At least 1, but hopefully 2. Maybe not 3. I don't want to bombard you with a review session every day. That's not a good idea. Maybe, hopefully 2. Alrighty, so today I would like to talk about aggregation and composition. All right. It's not a difficult idea. Okay. And let's now go over some terminology here. Okay. A little bit similar to when we define caller and callee. Now we have 2 words over here. It's called container versus containee. All right. It's not difficult. Let's now see example. But let's see the definition. Whenever you say an object is actually a container, that means the object actually contains other objects. And if you say an object that's being contained within another object, you call that object containee. It's kind of symmetric, like a caller and callee. Let's see example right away. So let's say if you have a class called course, another class called faculty member. So you would say each course has some faculty member as its instructor. That makes sense. Let's say we have a single constructor. In this case, who will be the container and who will be the containee? Let's take a look. So let me show you some diagram here. Right, some runtime structure. So let's say we got the course objects. Let's say we got 2 courses. We got 2030, we got 3311. And each course has its name, and also it has its prof, let's say instructor. For 2030, you can see that one contains a link to instructor, let's say myself. And another course contains another prof as the instructor. Right? So now as far as this relation is concerned, you can see for this link here, I'm going to highlight it. So you can see this one here and this one here. This one suggests some relationship between container and containee. So let me now annotate it. So you can think about this. These objects over here are the container, which contains a single faculty member as the course's instructor. This will be containee. And notice that here I say a single reference, right? You can see a course only has a single instructor. But there might be cases where an object may contain an array of other objects, right? It's also possible. But this is a simple case. And similar to the case where we got a caller, which might be a callee at the same time. Now, similar. A container may be a containee at the same time as well, depending on which link you're talking about. Let's now take a look. All right, container, containee. Okay, another scenario. Let's say each student, like you guys, is registered in a list of courses, and also each faculty member teaches a list of courses. So there are 2 examples over here, container and containee. For example, you can think about students is like a container, and courses will be like containee. All right, let's now take a look. Now, let's say we have a student here called Jin. So Jim has a list of courses, like an array. And the size here is not really important. I'm just showing 2, right, but multiple. So the first course Jim is taking will be 2030. And the second course will be 3311. Right? You can see there's a single container which contains multiple containees. And let's now identify this and then make the annotation. So you will understand pretty well the terminology. Okay? You can see this one here. For a single container, we got 2 containees. So let's now do this. So now as far as this one is concerned, you can think about this student object here is a container. And for the course over here, for that particular link, that's also the containees. All right? There's another one there, which I wouldn't draw. You can also try to see each professor also teaches a list of courses. That's also possible, right? You can try to annotate the diagram if you want to, but you get the idea. All right, let's talk about some property here very quickly, and then we'll see some example. So number one, so containees may be shared by different instances of container. So what does that mean? So for example, you can see here for, let's say for this particular course, okay, let's say for EECS2030. So for this particular object is actually shared by, number one, some students. Also number two, some faculty. Let's see exactly how. Let me sketch a little bit and then I'll write it down. It's important for you to also see the expression, okay? If you look at this object here, you can see there is one incoming arrow over here from the faculty side. There's another incoming arrow here from the student side. So that's what I meant. They're being shared. That's aliasing, which we spoke about earlier. And if I write it down, you will see. For example, let's say some students. So what I meant was, if you try to follow the path, let's say student S, and then go to their list of courses, and then go to index 0, that will give you the course, right? You can see S, the students, go to courses, which will give you the array, go to index 0, that will go to this object here. At the same time, if you try to go for the faculty, for example, faculty number 1 dot their teaching list, TE, and then go to index 0, right? You can see F1 is referring to this faculty here. If you go to their teaching list, go to index 0, that go to the same objects. Right? So that's really what I meant by sharing. And because they're being shared, if you try to write equals equals between them, it's going to give you true. Right? The same objects, aliasing. We're going to do another thorough exercise on how you can figure out the dot notation for the path today. That one's going to strengthen your understanding even more. But I think for this scenario here, it's rather obvious, right? You can see the same objects is being pointed to from different places, aliasing. All right, so let me just write down the word again. Just don't forget about the basics. Aliasing. All right, that's one property. And the second property is also very important. That would be something we have to contrast. So this is to say, let's say this. Let's say currently these two courses are being taken in fall 2024. Let's say when the semester ends, what's going to happen is we're going to put these two courses record maybe into a garbage collector. So they are gone because we already passed the semester. But in that case, should we wipe out this faculty and these students? Not really, because they still continue with their career, right? So that's really to say, whenever you got something that's being shared with the containee, when they got discarded, you don't necessarily have to discard the container at the same time, all right? That makes sense. That's good. All right, so far, we talk about some concept that's to do with aggregation. Aggregation simply means you have some sharing happening, all right? Okay, let me just go back here. And that will be some important distinction you have to make. Whenever we talk about aggregation, that means there is certain sharing happening or aliasing, as I illustrated to you. On the other hand, something that's called composition, that means we try to really keep the minimum sharing possible. But I'm going to show you how to do that. That'll be more worth our attention. Aggregation, that's something we have been doing since the beginning of the course. So I'm not going to spend too much time today. I'm just going to go over some example with you. On the other hand, if you think about composition, it should be minimum or even none sharing. All right, so we're going to pay more attention to composition for today because that's relatively new, but it's not too bad. All right, any questions so far? We're good? All right, hopefully it's still clear. All right, let's now talk about some example here. So let's talk about the file system on your Windows machine or your Mac, or just even the Linux machine in the prison lab. So we talk about directories. Let me give you one example here. So this will be something we got to try to implement as well later half of the lecture today. So let's say here, if you see there is one directory here on my desktop called D1, right? So this might be the simplest one I can demonstrate. If you go in and see, we got 3 files, F1, F2, and F3. So now imagine this. If I try to make a copy of D1, for example, make a copy, and then I'll paste it, right? It's something called D1 copy, basically. You can see we got another directory structure that look identical as before, right? You can see we got copy of F1. Now the F1 has nothing to do with the original copy F1. So if I do any modification, for example, if I say I want to change F1 into, let's say, F4, does it modify the original copy F1 here? No, it doesn't, right? So that one has more to do with composition idea, meaning that if you try to modify some copy there, it shouldn't really give you any aliasing effect. That's something we would like to implement today. I'm going to give you an example, right? But that's some conceptual example you can grab right away as intuition. Okay, let me close it and go back. All right, we got directory, we got file. So this one, I don't really have diagram here just yet. But I can think about directory contains file. Okay, that's why we got container contains. And we say that each file is really owned by the directory, meaning that if you actually try to change the file itself, it doesn't impact another file in another directory. Okay. And also, if, well, that one should be quite obvious. If I, for example, try to delete D1 here, afterwards, F1, F2, F3 are also deleted because they are somehow owned by D1. All right. Right, pretty straightforward concept. I think I just go over them, get some intuition. But I would say the bottom line is, whenever you want to distinguish between these two ideas, always remember, aggregation means you try to really make use of sharing, which is what we have been doing in the course. And composition is something like you want to disallow sharing as much as possible. I'm not saying 0, but sometimes maybe close to 0, depending on what the test cases tell you. All right. Alrighty. All right. I would suggest we go over a little bit about the aggregation first. All right. Okay, and there are several things over here I want to mention. Okay, so this has something to do with design. So in this course, you are not required to draw any design diagram like this. However, you will be expected to read them. But reading them is not too difficult. One thing you want to notice is you can see there is an empty diamond over here. So whenever you see this empty diamond, that means aggregation. All right? That means some sharing is expected. On the other hand, let me see if I have any another example here. Let me just show you very quickly. On the other hand, if you see a diagram like this, sorry, I don't have it, but it's on the slides, but I'll draw it right away. I thought I had it. On the other hand, if you see any solid diamond like this, okay, it's solid over here. If you see anything like that, that means composition. Just the diagrammatic notation. So this means composition. And that one means no sharing. So what you are supposed to read will be, if I give you something in the test, whenever you see there's a diamond here that's empty, that means we're talking about aggregation sharing. You should answer the questions accordingly. On the other hand, if you see the solid diamond here, that means we're talking about composition. No sharing should be expected. All right, that's a diagram notation. And in this case, how do you read it? We're saying that over here, a faculty over here, read it in this way. You can see this number here, and there, this is the attributes we're expecting to declare. Okay? This is to say a course by aggregation contains a single faculty as their professor. Okay, I'll write on the very first one, but later on you're going to use a similar interpretation. So this one is basically saying a course has, by aggregation, one faculty as its prof. Right? So now you can see that. How do I know it's aggregation? This tells me aggregation. And also a course, you can see the course over here. And then you can see faculty is a faculty over here. And then one comes from over here. And finally, you can see the prof is a row is here. Right? You can see a single diagram tells you many things. Right? That's how you are going to identify. All right. How do we read this one here? Very similar. The only thing that you should really know is the star over here means multiple, 0 or 1. That's the only new things. So this one here means 0 or more. All right, I'm not going to write it down, but let's practice how to interpret this. I'm saying a single student, a student has, by aggregation, multiple courses as their courses. All right, over here. All right. That's about design. So what you're supposed to really learn is how to read a diagram and know how you can do it, implement it accordingly in Java. Let's see how we can implement it in Java. What about this one, this single aggregation? So a course has a single faculty as their prof. Well, basically, as straightforward as this. You can see a course over here has an attribute of type faculty, prof. Very straightforward correspondence. On the other hand, how do we handle with multiple aggregation? Well, just using an array, right? Collection, right? Straightforward. And you basically have learned all about aggregation already, because once we have declared the courses array, it's really fall into our normal programming pattern. You know the rest. Okay, we just do one more exercise I would like to do to strengthen. All right, any questions so far? Aggregation. All right, if no, let me move on. Okay, let me assign some exercises to you guys. Okay, I tell you, because as I said, the aggregation is really about aliasing, which we have already covered. So we can spend a little bit more time on the composition today. So when you go over the slides, I think we have talked about this one here. Okay, so I would suggest, I'm going to maybe when I release the lecture material today, I'll mention the exercise again. So from slide number 12, which talks about the declaration of the classes and methods over here. And then this particular JUnit test, we got two test cases you will see. On slide number 13, this is one case. What I would like you to do, you can make a choice. Either you want to trace the code on Eclipse using breakpoint debugger, or you just want to visualize what's happening on a piece of paper. But of course, I'll be very happy if you do both. All right. That's test case number 1. And don't really think this is something new. It's really something we have learned already. But it's a nice exercise for you. Slide number 13 will be test case number 1. And also slide number 15 will be test case number 2. They just illustrate about, with aggregation, i.e. sharing, how objects are supposed to work together. Right? That'll be the exercise for you. What I would like to do with you would be some dot notation. I just want to revisit again because it's so crucial for your implementation. Okay. Okay. And this diagram here, if you think about it, you can see we got 3 associated. Oh, here. You can see we got 1, 2, and 3. We got 3 instances of aggregation here. A student, by aggregation, has multiple courses as their courses. A faculty, by aggregation, has a list of courses as their teaching assignments. Also, a course by aggregation has a single faculty as their prof. Right? You got 3 instances. So don't be too surprised if I give you a diagram like this later, similar, but you should be able to interpret them. You just got to identify how many empty diamonds do I have. Each one of them will be a single instance of the aggregation. And we're going to do some fun exercise. All right? But before that, I need to also give you some little bit contrived example just to clarify how you're supposed to call private attributes from your method call. That's also a valuable exercise for you. But I'm going to get to it. Let's go to it right away. All right, so this example here got quite many instances over here. I got a complete coding for you on the page. I will talk about 3 of them. That should be enough to really for you to grasp the principle. But afterwards, I'll leave the rest to you as exercise. All right? A little bit tricky, so that's why I really want to talk about it carefully. So there is some principle over here. Let me show to you, for example. We got 2 classes. We got class A. Also, we got class B. And what we're focusing on will be, you see all the attributes are private. All the attributes are private. So what I'll do is, for private attributes, I'm just going to box them in red. Private attributes. And for all the methods, like accessor, they are public. They're meant to access the private attributes. So these are the public methods. And also we got public methods over here. Okay, just in case you're kind of lost in the example, let me show you very briefly. We got some private attributes in A, object B of type B, integer of type integer. All right. Similarly, we got in class B, we got another private object of type A, and also we got another private integer bi. And we also got public method, get a B, which will return B, and get AI, which will return the AI over here. So here, get A is going to return this A here. Get BI is going to return this BI here. All right? That's what's happening here. The reason I want to talk about this is Java has some very logical but very tricky rules about how you can get access to private attributes when you try to make method call. A little bit tricky, but it's not too bad. It's logical. Okay. And I'm going to go over the principle just a little bit. It's very abstract. So let's talk about example first. I want you guys, first of all, to take a look at this one over here that's in pink. Do you think this guy here is actually going to compile or not? I'm talking about compilation. Intention is rather clear. This is referring to class A. I want to go to OB, which is declared over here. So far, good. That one there is B. That means we have to switch the context to class B right now. And then I want to get access to BI, which is private. That's the intention. Intention is clear on the paper. But the question is, does Eclipse allow this? You can assume there's a constructor. That's okay. Yeah. I like the precision, but it's not a focus point for now. You can assume they are constructors. Yes. Yes?
I'm understanding the model properly, since trying to access a private attribute from class B, we won't be able to use private to include the class B.
Okay, that's a very good point. So what you're saying is, somehow you're not able to access BI over here because BI is actually private. Okay? At the same time, I want you to consider this line here as well, and then I'll talk about it. Okay? How about this one here? Take a look. If I apply your logic, this is A. Go to OB, which is private. And then go to get A. Well, I already switched context to here, right? Get A is going to give me A. And then I'm going to say AI, which is also private. Are you claiming that in this example here, because I'm accessing AI, which is private, is also not going to compile? This will compile. Oh, so I got contradiction here. You'd only talk about private, right? If I'm accessing private, is it always allowed or not allowed? Okay. Okay, that's good. That sounds more precise. Yes, I agree. Yes, exactly. Good. All right, so guys, I want you to talk about these two examples, compare them. Once you understand the difference between these two, then you get an idea, right? So this guy here is not going to compile, first of all. This is not going to compile. On the other hand, this is going to compile. Before I go over the principle, let's now see exactly what's happening here. Let me write it down. For the first one here, we say, oh, I really meant this is the first one. This is the second one, all right? When I say this dot OB dot BI, since you're beginning to grasp this concept, I would say it might be easier for you to first of all identify where are the private attributes that are being accessed. For example, you can see OB over here is private. And also BI is also private. Right? You can see both of these are private. Let's start with the first one. When I consider this particular method call, attribute access, just this one here. Okay, just this one. This part is actually okay because this is actually A. And you can access any attribute you like in the current class. So accessing OB over here, which is declared just inside A, that's no problem. All right? This is okay. And if that's okay, we know that OB is going to give me something back that's of type B. And then this expression over here is of type B. And then we are trying to access BI. And BI, as you can see, under B is private. All right? However, this will not compile because if you think about the B here, and BI is also private. Let's make a note. Now, in order to determine whether this expression should compile or not, you want to see where is the context making this attribute access. We are basically writing this line over here in the context of class A. A does not match B, so it will not be allowed. That's the principle. Whenever you're trying to access some private attributes, you want to look at what is the context object type. If the context object type matches the current class where you're trying to make the attribute access, what method call, then it will compile. But in this case, it doesn't match. You can see B here doesn't match A, so it does not compile. All right? Does not compile because the context class is different. In this case, it's A. Right? So B and A do not match. All right? This is justification of why it wouldn't compile. And let's see why the other ones that somehow look similar, why would it compile? Let me mix. Okay, that should be good. Okay, good. Let me just move this a little bit away so I can make some more space for myself. Oops. Sorry, let me fix this very quickly. There we go. And then I'm just going to move this away. There we go. All right, let's now consider number 2. Number 2, let me write it down. Slightly more complicated, but it's not too bad. So I got this dot OB dot get A and then AI. Number 1, identify which attributes or methods are private. Number one. You can see the OB again, that's private, and also the AI over here, which was declared as private here. Right? You can see that one is also private, right? So we got two things to consider. Number one, this .ob is definitely okay. As we explained earlier, we're just accessing the private attributes from the current class. So this is okay, not a problem. And that one there is going to have type B. And then, once we are in the context of class B, we cannot access any private attributes, as we said earlier. But we can access any public attributes or any public methods. In this case, get A is declared as public, so that's okay. So this guy here is public, so that's good. So now, if we analyze this expression over here, this .obj.getA is actually going to give us something of type A. So now we are back to the context of A. And then, when we try .ai over here, AI, even though it's private, but that's okay. Access because the context of this line is the same. Namely, it's A. You can see we are writing this line over here in the context of A. And A here just matches the type of the context object A. They match. So that's okay. Sorry, not this. It's okay. Whatever. Okay, so A here and A here, they do match. All right, these are the two things I would like to talk about. All right, and your job will be put A and B into Eclipse. And then try all these lines over here. Eclipse is going to tell you the exact answer, whether each line should compile or not. And then for those lines that compile, convince yourself why. For those lines that do not compile, convince yourself why not. And the principle over here, what I just illustrated, will just apply. It's going to help you to determine. Okay, you need to exercise this. Yes?
So for like number one that's wrong. So we can fix it by just saying get BI?
Indeed, indeed. So what Robert just said is actually absolutely correct. So here you can see the reason that we couldn't really do that BI over here is BI is private. But I can do any public one. So you can say get BI. Yes, get BI. Indeed. Yeah. Question? Okay, any variance you would like to introduce, I would say try that on Eclipse first. And then let Eclipse tells you. But if somehow the answer you got from Eclipse seems very puzzling, come to me. Good. Yeah, the reason I didn't really want to go over every line here is it could be a little boring. So I chose the two typical examples. So you should really try to do that yourself too. That'll be the most effective way to really get convinced. But the principle is already there. All right. All right, any question? All right, this is relevant because when we do the, I'll get to you. The exercise that we want to do with aggregation actually need a little bit of knowledge from this. So that's why I want to talk about it more systematically first. Question? Okay, sure. So the difference between these two lines, again, that's really important. Number one and number two. Number one does not compile. Number one compiles. The reason is, for this particular BI, it is private. For this particular AI here, it's also private. All right? That's the same. That's what they share in common. What's really different is, if you look at the context object expression over here for BI, it is of type B. B is not the context class where you're calling this line. So that's why they don't match. So it doesn't compile. On the other hand, if you look at what is the type of the context object for AI, it is this expression here. This is of type A, which is just the same class where the line is being used. If they match, then it will compile. So always, if you got some expression like this, let's say private attributes, and you got some complicated expression as a context object, look up the type for expression. If the expression happen to be X, then compile. If the expression happen to be something like a Y, then it doesn't compile. That's the principle. The principle sounds easy, but it does require some practice before you really got convinced and being able to do it on your own. Jennifer, is it better?
Yeah, so B is a context object, but BI is an attribute from the class of B.
That's correct? No. You might be, yeah, I know what you mean. Intuitively, you might be thinking, well, if this is B, I'm just trying to access BI from B. But the problem is, where are you doing this line here? You're doing that from A. A should not see any private attributes in B. That's a problem. If you write this on the paper, I will understand what you mean, but compiler wouldn't. Okay, that's the thing. Again, for here, I understand that intuitively, this guy here is B. B.bi sounds very reasonable, but the problem is this is private. So any private attribute should not be visible to any outside class, in this case A. So that's why it wouldn't compile. All right? Okay, any other questions? Good question, good. All right, let's now do some exercise. You'll be a little bit more, slightly more interesting, not just contrived. All right, so what we're going to do is, let's now, before I get to the exercise, I got 3 sets of them. They're pretty straightforward, but let's now make sure we do them together. So this will be the runtime structure I will assume, right? That's something we did earlier. So we got 2 faculty, we got 2 courses, we got 1 students. And each course has a single instructor. Each faculty has a list of assigned courses. And each student has a list of courses they are taking. Right? So these are the aggregations we want to focus on. And let's do something very useful for you. The idea will be, whenever you're implementing a method, what dot notation will be considered as valid depends on what the context class is. When I say context class, I'm really talking about if I'm trying to write the same dot notation. It might compile if I try to do it within the context of the student class. But it may not compile anymore if I move to another context class. So that's why we want to do the exercise. So here is the roadmap for the exercise. We're going to focus on 1, 2, and 3. These 3 methods will be implemented in the context of students. Exercise number 2. We're going to switch the context to the course class. And then we try to implement 1, 2, and 3 methods. And then we switch to the context of faculty, and then we try to implement another 2 methods. The runtime structure is really the same over here, but it's really about where the starting point is. The starting point could be from a single faculty, the starting point could be from a single course, and the starting point could be from a student. So that's why it's going to make a difference about what dot notation is going to compile. Right? So that's kind of what you want to grasp, right, in the next 3 examples. Okay, let's try the first one. Again, let's say in the student class, we got 2 attributes. We got ID and we got courses. And we want to implement none, 2, and 3. All right, the first one is pretty easy. I don't need to bother you. How do I implement the get ID? I want to get the ID of the students. You just return this .id, right? Let me ignore the return statement just to save some writing. And according to what we learned earlier, this is students. ID is private, no problem, right? How about this one here? I'm taking some integer I. For example, if I got index 0, that means I want to get the course, the title of the course taken by the students that's stored at index I. What should I return? For example, if I say Jin.getTitle 0, that should return back to me advanced OOP. What should I return in the method? What should I write? Anyone? Robert. I. Yeah, that's perfect answer. I like it. Yes. So this one here is going to be this dot CS, which is here, and then at index I. Oh, not 0, I. Of course, the I over here is assumed to be valid, right? All right. This one's similar, but now rather than returning the title of the course that's stored at index I want to return the name of the instructor for the course that's stored at index I. What should I return? Of course, you want to get to the course first, right? Go to I. And what else? As soon as I got to here, that means I'm not in the context of course. How do I get to the name of that particular instructor for the course? What should I do? Dot what? Dot title? Anyone? I'm only going to bother you for this one. How about that? And I'm going to tell you the answer for the others. Come on, somebody? How about you? What should that be? Prof? Then? But I want a name, which is string. I don't want a faculty. What should I do after that? How do I get a name? Well, you just get a name, right? All right. Okay, I know you guys are shy, but hopefully you kind of get an idea, right? I presume silence means you are really getting it. All right. Dot get prof, and then get name. That's what you got to write. However, there's something I want you to think. Would it be okay if I if I replace this one just by prof? Would it be okay if I replace this one here just by the name? And in order to answer these two questions, you have to look back to the exercise. All right? And you really want to get through this. All right? All right, any question? Here. Yes?
For the get title, right? Why didn't you do like CSI and then you didn't like get title?
You're talking about the purple one, right?
No, the green one.
The green one?
Like that's what
Yeah, I agree. Yeah, sure. I just forgot. That's a good catch. And here, of course, you can say get title. And you can also think about what if I say, rather than get title, I say title. Would it work? Right? Would it compile? That's what I meant. Conceptually, I know it will work, but on the Eclipse, you gotta follow the compilation rule. All right, let's now switch the context. What about if that's a course? All right? How do I get the title of the course? Well, just attribute access. I can say this dot title. Okay. All right, you may not like this. I'm going to point somebody. That might be fun. Okay, the second one. Given the course, for example, I want to know the name of the instructor. Oh. Okay, I'll start with, would you like to try? If you want to pass, just say pass. Pass, all right. How about you? Also want to pass? You? Wow, oh, pass, wow. Well, of course, you want to pass the course, right? But not passing this. Oh, my God. Robert.
So would it be this dot back, this dot prof dot get
Name, yes, exactly, over here. All right? For those of you who passed, don't feel bad. You really want to get through this. Maybe that's new to you, but you really got to make sure you know how to do this, right? This prof dot get name. Okay. How about next one? Everybody? Gabriel. Next one. Ah, you got to pay more attention, right? All right, that's okay. Would you like to try? Get your head around. That's okay. You know, that's okay. Okay. Since like I'm the one understanding all these, so let me share my thoughts then. What should that be? All right. So now for this one here, for example, if you look at this, I'm now in course. I want to get, excuse me, I want to get, oh, this one is actually complicated. How about we do that together, okay? So let's say I got a course over here. I want to get the title of this course's instructor's ith teaching course. So what do I mean? Let's say I'm course over here. I want to get its instructor, in this case myself, and for that instructor, I want to get their ith teaching course, which can be 0 or 1 or 2. Get to that particular course, and then I want to get its title. All right? I'm going to write it down. This might be by far the most complicated one. I'm going to say this dot get prof, or I can say prof, that's okay. And then once I get to the prof, I want to know their teaching list. So get the teaching list. And once I get the teaching list, I'll get to this array. And I might want to go to ith of that array. And then I might get to maybe, for example, this course, for example. If I get to the course, I want to get its title. Well, again, exercise for you. Can I try TE over here? Also, can I try title over here? And when you actually do the review for your exam, for the written test, you got to make sure you're very comfortable with doing something like this. All right? That might be the most complicated one. All right? Okay. If you feel struggle, that's normal, but you just got to get through the struggle. My role in the class is to challenge you, but hopefully you'll get through. All right. For the next one, basically similar. That's going to be basically we change the context to faculty. So once we change the context, how do we implement these two? All right, so these two, you can find the answer in the slides, but exercise. All right, exercise for you guys. All right, any question in general about the aggregation so far? So basically, I think today we learned about several things new, even though it's about aliasing. Number one, how can you define, how can you decide whether the dot notation should compile by accessing private attributes? Number two, how do you implement the methods by using dot notation, by switching to different contexts of the class? All right. Yes?
Can you go back to the previous slide?
Of course I can.
So you see the highlighted for the third box?
Mm-hmm. You mean this one here?
Yeah. This dot prof dot get teaching list.
Mm-hmm.
And then you have this square brackets there. That's like the correct.
That's a correct syntax. Yes, indeed. The reason that this is correct is when you get to this part over here, you can easily figure out the TE, get TE, is going to give you a course array. So once you get to the array, of course, you can use the index notation. Of course. Okay, I'm glad you asked. All right. All right, let's now move on. And the next one will be composition. Okay, how about this? Why don't we take a very short break by taking attendance and we'll do composition. That'll be the last topic. All right, so I believe we got some question from before the break. Yes, go ahead. Which page are you talking about?
So what indexing on the labs, I often am running into the issue where I try to invoke that dot operator on a null object. Usually I just run a statement that says that it's null and just skips that iteration.
Okay, maybe some specifics about your lab, but I think maybe let's talk about it after the class. Mm-hmm.
Let's say for whatever reason the index we have has a null object
Mm-hmm.
and list of size 10, there's only 5 objects.
Mm-hmm.
Once you're at the 6th iteration, you'll try to invoke a dot get null object. Is there like say you can't invoke that on null, I don't know how to manage that.
Well, basically, you're more talking about runtime check, right? It has nothing to do with compilation. So whenever you got some indexing notation over here, of course, all compiler can do is to check to see whether the type is okay. But it doesn't check anything about whether this particular I value is going to cause any index out of bound exception or null pointer exception. So your safest bet is to do two things. Number one, you can say, I want to make sure that I here, you can say if, of course, you can say it's a valid index. It should be between 0 and the dot length minus 1. Number one. Number two, you can also say, at that particular index, the object is not equal to null. These are the two things you should do. Yeah, okay. All right, any other question you want to follow up for you guys? Yes? Mm-hmm.
I'm assuming it's because like we're currently in the context of our prof came from it.
Mm-hmm. Yeah, so yeah, sure. Yeah, just for this one specifically, you can see that here, if I got this .prof, apparently this one is actually going to give you over here, this .prof is going to give you instructor class, which is faculty. And then you're trying to get access to this particular course. And course is a different class. Of course, they don't match, so you wouldn't compile. Because get TE is going to give you the courses array. That's a course. Oh, sorry. Sorry for confusion. So this one here, let me see this. So this one over here, all right, guys, please, discussion, keep it none, please. Okay, this .prof is going to give you faculty, right? And the faculty over there, and then you're trying to get to TE at index I, right? I'm talking about TE over here, all right? So TE is actually over here, and that one there has the course, all right? And then we have the course. Okay, that's fine, sorry. And the course over here matches where the context is, which is course. So that one's fine, yes. But of course, verify that by the compiler. The principle remains the same. You want to really see whether the context object over here is really match, okay? The principle that we said before. Okay. All right, so again, try this out. I would say try first the example over here and try to see whether compile or not really convinced you. And then if you want to go more, you can definitely try each of the possibility. And I will see maybe next time as a recap, I can go back to here and then talk about a few more just to be sure. Okay, I can do that too. Okay. For now, let's now talk about something else. We got 18 minutes. Okay, so let's now talk about composition. So idea about composition will be no sharing, right? But what do I really mean by no sharing? I'm going to explain that by using some assertion checks or just checking some value. That's something we'll see. All right, the dot notation, you can see all the solution over here. All right, so now the composition, one thing to note to is you can see that over here we got this one here, right? You can see the diamond shape is solid. That means we're talking about composition, so no sharing, all right? And then we are just going to assume private attributes, public accessor, and let's now go over some code just to set the context. Okay, so we got directory here. Let's start with the file. So we got a class called file, and then the file has a name. That's the only attributes. And we got a constructor over here, which will create a file with a name. Easy. And then we also got maybe another public accessor. Oh, sorry, not here. I'm talking about directory here. So the directory class over here, we got the name of the directory. We also got an array of file. And then we got an integer counter. And we got a constructor over here, which will take the name of the directory. In which case, we're going to create 100 slots for the directory. So maximum 100 files in the directory. And then we got add file, which is going to add some file with the name, right, etc. Right, pretty straightforward. No surprise. And we also got some public accessor here, which is going to return an array of file, depending on what the value is for NOF. Right? We have done this many times in the lab. So let's now try to run some test case just to see what's going on here. So now we got some directory, let's say D1. Right? We're just creating D1, which has the name D. And also we got initially NOF would just be 0 initially. All right? Initially it would just be 0. And then we are trying to add a file 3 times. 1, 2, and 3. Each one of them is going to trigger some new file to be created and assign them to the right spot. Okay? And then we're going to, let's say for the very first one, it's going to create this file with F1 and then store that at index 0. And then update the count to 1. And then the second one here is going to create this file for F2. And then store that at index 1 and increment from 1 to 2. And then the third one here, F3, is going to create this file and then assign that to index 2, right? And 3. Nothing surprising. Okay? And one way to, we'll get to composition in a moment, but you can see that right now there's only one directory where we got only one incoming arrow for each of the files. So there's no sharing just yet. But we'll see how sharing might happen, which will violate composition. And you can do some easy assertion. You can just check to see whether the name of the file over here is equal to F1. Okay? So guys, you really don't want me to say that every time, all right? I really want to keep it not so extreme, but if you do it again, I really don't want to get to the worst case. Please. All right, so let's now move on. So here we got only this file here, the file number 1, file number 2, file number 3. You can see all 3 of them only belong to directory D1. But we're going to see how it is possible to have another directory object that's also going to share these 3 files. That's something we'll see. And we want to disallow that for composition. All right, let's see how that can work. Let's now see some extension. Okay. What I want to show you is, let me see some slides. Shallow copy. So we're going to see something called shallow copy, which is on the way to implementing composition. But shallow copy may not be enough. That's something we want to illustrate. So let's see directory here. And we have a constructor over here, right? That's something I want to show you a little bit on the slides. Okay? Okay, so this is something we've gone through, all right? That's one has been done. And then that's a diagram I just drew to you. And this will be a new term for you to understand. It's a copy constructor, which is actually a very simple idea. So what do I really mean by copy constructor? It's just a constructor. The special thing about it is the parameter type. So if I have a class X, and then let's say public class, and I try to declare some constructor, public, I know that by convention, the name of the constructor must be the same as the class name. And it would be considered as a copy constructor if the parameter I define over here has the same name or has the same type as the current class. And then here I can say, for example, other. And you can see that over here, X matches X. And this will make it a copy constructor. Okay, of course you can define some stuff over here, right? So this is what we call a copy constructor. All right, so that's something we'll talk about. And we're going to implement the copy constructor for directory in a way that's going to implement composition, meaning that the files that we're going to copy should not be shared between the 2 copies, right? But how do I mean? What do I mean by that? So we're going to see that exactly in the example. But just understand the copy constructor definition first. How can you identify copy constructor? That's important. All right. Let's see what we have to do over here. So I can tell you first, the shallow copy that we're going to talk about is easy to do. It's easier to code, but that one wouldn't exactly satisfy composition. But let's see why. So for the directory, we still have the name and also the array of files and also NOF. That one's the same. But what I want you to focus on will be the copy constructor over here. It's a copy constructor because you can see directory and also directory, right? That makes it a copy constructor. I basically want to create a new directory object using the constructor from just another directory. All right? And what do? I simply say the NOF for the new object should be other.NOF. Just copy that. And I want to say the name should be other.name. And the last line is the highlight over here. Files will be assigned to other.files over here. Okay, this is important. This is what I meant by shallow copy. And I'm going to visualize to you, but for now, this is where the shallow copy comes from. Just copy the reference of the array. That's what we're doing. And as soon as I visualize how this is going to work, you will see that somehow we are really sharing the files between the two directories. But let's see how. But you want to understand this word first, shallow copy. That means we're using the variable assignments only for references. Okay, let's see. Number one, let's now have the directory. Directory D1. All right, you can see D1 over here is going to be created, like what we said before, it's going to be of type of name D, and then we're going to add in F1, F2, F3. F1, F2, F3. That's what we did earlier in the page. And let's now try to call the copy constructor, this one here. How is that one going to work? That one there is going to create just a new directory object, D2. So D2 is simply going to point to a new directory object over here. And then when you try to execute the directory constructor, which will be here, and then we're going to copy the attributes one by one. NOF at the moment is 3. Copy that over to, oh, sorry, let me say it the wrong way. You can see D1 over here is basically other. All right? And then you're saying NOF over here should be D1.NOF, which is 3. Just copy that over. And also the name over here will just be D1.name. That one there is more like a string, so we are also having some, we have some sharing already. You can see the name here, right? That's already sharing. Most importantly, when we try to do files over here, which is referring to the files in this D2, is going to be other.files, and other is D1, D1.files. D1.files is really pointing to this particular array. And we're saying that it's going to point to just the same array over here. All right, that's really the essence for like a shallow copy. You're basically letting the two directories share just the same array. The same array of files is being shared between the two directory objects. So that one there is not really composition, right? And then for that one there, you can say D1.files, D2.files, they are the same objects. D1.files and also D2.files, they are the same objects. And then this is important. This line here is going to illustrate how the violation of composition occurs. let me highlight this one here. Composition tells you, if I modify the files of one directory, it shouldn't really impact the file of the other directory. It shouldn't. But now, would it? It would. If I say d2.files 0, so d2.files at index 0 over here, I want to change its name to maybe F11. If I simply modify that, you can see that one will follow this link over here. I want to change that to be f11.txt. I'm trying to modify just one file from D2, but is it going to impact the file for D1? It is going to, because if you see D1 and then you go to files, go to index 0, it's pointing to the same file. So it also has been modified to the same name. So you do see the impact. Also modifies a file shared by D1. So this is really something you want to notice. That's a violation for composition. Okay? And we just verify that to say the file from D1 is not F1 anymore, because you can see assert false. You can see it's not F1 anymore. It's simply F11. All right, quick recap. This page over here tells you, number one, how you can declare some copy constructor. Number two, we don't really do any deep copy. We just do a shallow copy. Just copy references from array into array. In that way, you really are sharing array objects over here. You can see one is here, the other one is over here, right? You're sharing the array. But somehow, if you want to modify the file here from one directory, it's going to impact the same file from the other directory. All right. All right, any question? Question? Yes.
So for D, they're pointing to the same like string variable as D. So that one break points is because when
yeah, this one is interesting. I do see your point. So first of all, we got to make sure we understand this array is being shared by both directories. We know that violates. Would this actually violate composition? The answer is no. I'll tell you why. It's a little bit weird because in Java, the string is so-called immutable. It is not possible for you to somehow modify the string object here per se. There's no such method to support it. So that's why I kind of avoid talking about it. Okay, so I can make a note here. So this, you're right. This string object is being shared. But there is no such public method in the string class for you to modify the contents of the string. For example, you may want to modify maybe from D into, for example, D1. You cannot do that. There's no such method. All the methods in string class is immutable. Okay. Not violating composition because the string is immutable. All right, that's important to know. But understanding this one here is the most important, the file being shared. All right. All right, I got 2 more pages. I would suggest I continue with these 2 pretty quickly from Tuesday, and then we should be able to move on to inheritance. I just want to draw your attention to one exercise, which I would highly recommend you try. Okay, so let me just give me one moment. I'll show it to you. If you go, let me see. Okay, if you go to the E class, okay, I'll show you a way to get that file. Yeah, bear with me 1 more minute, and then we should be done. Yeah, let me just get this verified. Okay. Right, if you go to the E class and go to the announcement, and there is a link to the file. Sorry, it's been slow, but almost there. All right, if you go to the announcement from yesterday, so there is an announcement about design exercise. All right, go to the announcement, and then there is a link, which I want to show you very briefly. Okay, if you click on the link, so there is a PDF there. All right, so this is some example which we'll start talking about from Tuesday very, very extensively. What I want you to do is, before Tuesday, think about exactly how you can design classes and methods for this particular problem, student management system. This is going to be very valuable because given that you have not learned about inheritance, what will be your intuitive solution to this? And then you got to compare this solution here with how we use inheritance to make it elegant solution. All right, so that's something I want you to try. All right, I'll see you next week.